Graphing calculator on her desk. This is still section 5.4, complex numbers. Yesterday we learned what a complex number is. Go ahead and tell your notes and we'll go from there. Yesterday we learned that if we have something like I squared, that's equivalent to what? -1. We also learned that if we take the square root of -1, that's equal to what? We're going to use those concepts today to solve some equations. To start off, we're going to look at a graph. I want to solve this equation. Would you please copy it into your notes? 5y squared plus 20 equals 0. This is a quadratic equation because it has that y squared. We learned before Christmas break that we can solve quadratic equations by graphing, correct? I would like for you to take your graphing calculator and graph this quadratic equation. So we're going to go to y equals. If there's anything typed in, go ahead and clear it out. We're typing in 5. I'm not going to use y. Let's just use x just to keep it easy to type in. 5x squared plus 20. Now where do we go to see a picture of our graph? The graph. Looks like mine is super zoomed in, okay? I'm going to have to go to zoom and then zoom standard to get back to my standard viewing window. So I went to zoom and I'm going to click number 6 to go to Z standard. Zoom standard. So if your graph doesn't appear either, you might have to do this. It's still not there, is it?
Mine's like more different.
Now, let's back up for a second. What is the y-intercept on this graph? What's our c value? It's 20. Our y-intercept is way up here at 20. We can't see it yet. So let's change our viewing window. So go to window, please. And I want to change the maximum y value. I don't want to type in 20 because it's not going to be enough. Let's type in 30 under our y max. If you change your y max and your y min is -10, x min is 10, y min or x min is -10, you should be able to graph it now. Anybody not get theirs to graph?
No, change, leave that one right there, the x min is -10. X max is 10. Change your y. We want to change the height of y to 30. Now go back.
Anybody else unable to get the graph to appear? Okay, so we were finally able to get it graphed. What are the solutions? If you remember back to last semester, our solutions are where it crosses the x-axis, right? Where does this graph cross our x-axis? It doesn't. So what did we say when it didn't cross the x-axis? We said no real solution. helpful to just sketch a picture of what this graph looked like. Something like that on our y-axis. The y-intercept there was at 20. If you sketch a little picture so that when you reference this later, you'll know why you did what you did. Now, it doesn't have any real solutions. So if it doesn't have a real solution, what kind of solution do you think it might have? It has an imaginary solution. And I'm going to show you today what that imaginary solution is. I can't graph it and get a solution. That doesn't tell me enough information. But I can solve it and get a solution that way. So to solve this, we're going to solve it just like we would a linear equation. I can't really factor. I could factor out a 5, but that's going to leave you with y squared plus 4, and there's nothing I can do with that. So factoring won't work here. Instead, I'm going to solve it like a linear equation and get that y squared by itself. To get y squared by itself, I'm going to begin by subtracting 20 from both sides of the equation. And I'm left with 5y squared equals negative 20. To get y squared alone, do you agree you would divide by 5 on both sides? Okay, go ahead and divide both sides of your equation by 5. Everybody okay at this point? Now, I'm solving for y. How can I get rid of a square? Take the square root. So what I'm going to do is take the square root of both sides of my equation. That's kind of something we haven't talked about a whole lot. To get rid of a square, we would take the square root. Anybody know how we would get rid of a cube? We would take the cube root. Okay, to get rid of the fourth power, we would take the fourth root. We'll talk more about that later on. Okay, so what do we have left? We're actually going to have two answers here. There's a rule in math, and it says when you add a square root to a problem, you have to have two solutions. You're going to have a positive root, and you're going to have a negative root. If we add the square root to a problem, we have to add in plus and minus. Square root of negative 4. Well, the square root of negative 4 is something we can simplify, isn't it? We learned how to do that yesterday. So let's go ahead and simplify that. Just going to bring down the plus and minus. We can make this negative 1 times 4. What is the square root of negative 1? I. And the square root of 4 is 2. So I'm going to say plus and minus 2i. Square root of negative 1 is I. Square root of 4 is 2. Plus and minus 2i. Lila.
Why can't you just change it to like negative 2? Like
right here?
Do that, yeah.
If you type in the square root of negative 4 in your calculator, go ahead and type it in. Square root of negative 4. It gives us an error because we have to put an I in there. Okay? If it was a square root of 4, we could say it's 2. But if that negative's under the square root, we're going to have an I in our answer. Good question. So this is the solution to that graph. It's plus and minus 2i. What that means is we have two answers. One of those answers is a positive 2i, and the other answer is a negative 2i. At this point, you guys can't graph with imaginary numbers. Okay, so this is all, at this point, this is all you need to know. That the solutions are positive 2i and negative 2i. And you can leave your answer written like this. Let's try another one. 4x squared plus 256. We're not going to graph this one. I'm going to tell you that it has no real solution. The solutions are imaginary. So let's solve this. To get x squared by itself, what would you do first? So let's subtract 256 from both sides. We have 4x squared equals negative 256. What would you do in the next step? Just divide by 4. So x squared equals, so we have negative 64. We want to get x by itself, not x squared. So how do I get rid of a square? Get the square root of both sides. Go ahead and show that stuff. Try to do too much in your head. Show that stuff that you're writing it out. Now we learned just a second ago that if we add the square root to our problem, we did here, we have to account for two roots. So we're going to put a plus and minus, meaning there's going to be a positive root and a negative root. Plus and minus what? Square root of negative 64. I hope you guys can see that. What is the square root of negative 64? 8i, isn't it? Because the square root of negative 64 is like the square root of negative 1 and the square root of 64. That's 8i. So we're going to say x equals plus or minus 8i. Now sometimes this number is not a perfect square. Okay. Yeah, we'll do one next without a perfect square. If that's not a perfect square, we'll just simplify like we did yesterday. Let's look at one where it's maybe not a perfect square. Oh, good question. You can leave it just like this. If you wanted to write it twice, it would be your something. But I'm okay with you leaving it like that. Good question. I'm going to give you a different problem. We're not going to do this one. Let's do this one instead. 2x squared plus 100 equals 0. To solve this equation, what should we do first? Subtract 100. So 2x squared equals negative 100. Do you agree we divide by 2 next? We can't take the square root too prematurely. We have to have x squared by itself before we can add in that square root. So don't get square root happy on me. Divide by 2, we have x squared equals negative 50. Now that x squared is by itself, we can take the square root of both sides. So I added in the square root to the problem. What else do I have to add in? Plus or minus. Plus or minus the square root of negative 50. Now, 50 is not a perfect square, is it? Okay. So let's just simplify it. What number goes into 50 that is? 25. So I can make this negative 1 times 50. Square root of negative 1, of course, is I. And then I can make 50, 25 times 2. What is the square root of 25? 5. So we could say 5i square root of 2. plus or minus 5i square root of 2. And again, that's all we can put for our answer at this point. There's no way to graph it, and I can't even figure this out by graphing. The only way I would be able to solve this equation is by doing this method right here. I'll show you some other methods as we learn some other methods, but at this point, we can solve by graphing, or we can solve, this is called kind of the square root method, the square root of both sides. But this is all we can do. So today we are solving quadratic equations that have imaginary solutions. And we're using a method, it's technically, I guess you call it, the square root method. Square root property. You do need